And welcome everybody to the Daily Space Weather. We're delighted that you found the channel. Today we're talking about how the coronal mass ejection watch continues despite low solar activity. So first thing we're doing here is we're looking at the closest star, El Sol. We did see a sunspot spontaneously appear once again. Sunspot 3840 rather, is this one right here. It has promptly degraded. We may go back to 0 sunspots today. Here's another view colorized magnetogram. You can see that sunspot forming and then moving into a setting mode, almost in the same location where we saw sunspot 2838. The one that produced, was it 3 M-class flares and an X-class flare, the largest solar flare since September 2017. And here's ionized helium, 304 angstroms. There are some filaments in between Earth and Sun right now. What the heck? It's playing slowly because reasons. There are filaments between the Earth and the Sun right now, and those do have the capacity to be released spontaneously without any sunspots and without any solar flare. So that's something we'll be keeping an eye on. If we do see a coronal mass ejection, we'll probably make a video about it. And here's a diagram of the solar system if you're wondering where stuff's located today on 7/7. There's where things will be in 7 days. And the 10.7 centimeter radial flux has dropped all the way down to 83. Here's a 1-year chart of that to put it in context. A little bit of a sputtering here of the ramp up of solar cycle 25. Black line is the radial flux, red line is the sunspot number. No solar storms or geomagnetic unrest or anything forecasted here by NOAA on the Space Weather Enthusiast dashboard. Let's talk about global seismicity. We're seeing a massive earthquake drought. There's the 90-day bar graph, and you can see only one 7-magnitude earthquake over the past 90 days. So here is the last 24 sorted by 4+ magnitude. We did see a 4.1 magnitude earthquake there in Montana. Anyway, here it is sorted by 5, so we see 3 here in Oceania, south of the equator. Let's roll up the list. And since this one occurred nearly 24 hours ago here, let's just take a look at that one real quick. In eastern Montana, a 4.1 magnitude quake there. In the Bull Mountains. Anyway, not far from Yellowstone, near Billings, felt by Billings, Montana. That 4.1 magnitude quake. If you felt it, let us know in the comments. And back to the list here. Let's scroll up. So we did see a deep quake in Colombia. There was a 4.9 in Iran also. The Bonin Islands near Japan, south of Japan, saw a deep quake at over 500 kilometers depth and a 4.0 magnitude. Guam saw a deep quake at 4.3 magnitude at a little over 119 kilometers estimated depth. Also a 5.0 at Guam. There was a 4.9 in Indonesia, a 5.1 at the Solomon Islands. There's a location of that. Northeast of Australia. A 5.3 struck Lakhimpur, India. And largest quake of the past 24. Was a 5.7 at the Fiji Islands, it looks like. That one at extreme depth, 536 kilometers. If it happened at the surface, it would be more like a magnitude 7 quake. 5.7 south of Fiji, in the Fijian Trench north of New Zealand. Largest quake of the past 24 hours. And let's check volcanoes. as there have been a number of them erupting, including Etna, which has been producing a 20,000-foot ash plume over the Isle of Sicily. Karimsky now back on the list. As it explodes, it's been producing a 9,000-foot plume of volcanic ash. Suwanosejima volcanic ash cloud unknown. Please don't hang glide over the caldera. Tal volcano there near Manila, Philippines. Small eruption there, 2,000-foot ash plume. Luatolo in the Lesser Sunda Islands produced a 9,000-foot ash plume. Fuego exploded in Guatemala, produced a 15,000-foot ash plume there. Nevado del Ruiz dispersed its volcanic ash. No more ash plume over Colombia. Sangay in Ecuador exploding, 21,000-foot ash plume there. Flight level 140 over Revenador at the Ecuador volcano. It's a 14,000-foot ash plume. A great reminder to not pole vault the caldera. Please don't pole vault the caldera, folks. It could be unhealthful, and we would prefer our viewers to be healthy. So maybe pick up some merch, tell your friends and foes not to pole vault the caldera, and about the channel. And once again, congratulations on finding out that the channel exists. This public service message brought to you by smAsho.com. Here's the GOES X-ray flux over the past 3 days. As measured by the GOES 16, we did see 2 C-class solar flares over the past 24 hours. Likelihood of solar flares has gone down as we see very little sunspot activity. No strikes in the proton flux, no coronal mass ejections headed Earth's way. At least not that we've currently noticed. The GOES magnetometer there over the past 3 days, looking a little spiky. And we will probably see a progression of the heliospheric current sheet polarity now. Let's take a look at it. And here is the heliospheric current sheet shown in polarity, red for South Pole, green for North Pole. And Earth may be approaching another North Pole current sheet here. Doesn't look like it, though. Anyway, here's the latest image. Earth looks solidly in a South Pole current sheet. Also, you can see all these bunched up lines here. These are some of the indications of the plasma between Earth and Sun. There also is a little bit over here, but it's mainly this area. Here's a line of sight. Ecliptic plane field plot. And we actually do have some coronal holes. Here's imagery of the line of sight coronal hole plot, which also shows the Sun's B field in blue, and you can see some South Pole oriented coronal holes rotating in here in the southeast. Perhaps some coronal holes here providing some geo-effective solar wind if those stay intact. We'll be keeping an eye on them, seeing if they're going to be putting an ion or two on planet Earth. So here they are showing up in the detected coronal holes imagery. 2 rather significant ones. Probably something like 4 days, and we can expect to see some high-speed wind from those. And here's your detected sunspot groups. Pretty much all sunspots looking weak here. In fact, we can barely even find any umbrae on the imagery. We'll show you the high-res stuff at the end of the video. There's the KP index, a global geomagnetism measurement, having been at a KP of 1 here for the past 9 hours. Next, the real-time solar wind, to see a pretty uneventful solar wind, although we did just see a little uptick in the density here. So that actually looks a little bit like a coronal hole wind stream already, as we do see the BTBZ converging on the 0 line here at the same time that we saw an uptick in the solar wind density. Anyway, current conditions are around 12 protons per cubic centimeter for the solar wind density, solar wind speed 361 kilometers per second. Looks like a fairly diffuse and weak coronal hole wind stream, but anyway, here's the magnetohydrodynamic pressure over the past 4 hours. We can expect to see an uptick here in the second half of the video. And you're looking at Magnetohydrodynamic pressure here in nanopascals. Around the geospace, let's see if we see an uptick in the pressure. There's that uptick in the pressure that we forecasted by looking at the real-time solar wind. Here are ground magnetic perturbations, changes to Earth's own B field, geospace delta B. We show it daily, 4 hours of data here. And we see, once again, significant ground magnetic perturbations here in the portion of Antarctica south of South America. So you can see some over the Canadian North Pole, a little bit over the Siberian North Pole, some associated with the South Geomagnetic Pole, and some down here. So we've been covering that for quite a while on the channel. I'll let it play through a second time there during this geomagnetic excursion. Please leave us a comment if you're very, very frightened, scared, and spooked of the geomagnetic excursion. Leave us a comment. Let us know how scared and spooked you are and how you got so scared and spooked. And we would remind everybody to press like and subscribe if you enjoy the content over on YouTube. Please tell your friends and foes we need your assistance to get the videos out there, as the algorithms do not seem to like us particularly much. Press like, press subscribe, press share. We're on BitChute as well. We're also on Discord. You can find the link there. Today's featured product is available at the smAsho store. And you can find the link to that at our homepage. Right there, the smAsho store is what we're looking at here. That's what the smAsho store looks like. Are you safe yet? Well, again, we would prefer for you to be safe. Whether it's from nonsense and propaganda, or whether it's from the COVID, or whether it's from whatever. The featured product is smAsho Price, my first pandemic t-shirt. I've got one. And it's an homage to the pathetic and infantile response of mankind to the COVID, the Rona, the SARS-CoV-2, where mankind decided they're going to put a mask on the planet, an utterly ineffective and ridiculous solution. A ridiculous non-solution. Anyway, check out smashamash.com. You can find our social media links there. There's the Discord link. You actually need an invite, and that's a permanent invite link. We'll also be streaming live this afternoon, by the way. If you weren't aware, we do Wednesday afternoon live streams at 2 p.m. And we'll be inviting our patrons to a Zoom call once again for that. Welcome to the Neo-Renaissance. And we're going to do a short cosmology segment today showing this simulation here of the Orion Nebula. So this is the astronomy picture of the day here. This is a bunch of infrared data. And it's going to turn into essentially a 3D fly-through here. It's quite good. So after all these animations happen, this thing's going to rotate. And again, this is all based on real data. This is not really a simulation. The Orion Nebula, located about 1,500 light years away. And there's the three-dimensional view of that. Spectacular imagery there. The data is from the Spitzer Space Telescope. And again, that is all infrared light. Quite a great three-dimensional view of the molecularly complex Orion Nebula and the thermal spectrum coming out of it. Infrared light. And let's pick a random number here. Today's random number is 77, which is not AU microscopii. We'll talk about that at a later time, though. 77 is a quasar, apparently. Quasar J0221 plus 3556. A type of active galactic nucleus where the galactic jet is oriented generally directly toward you, the observer. And there are the X-ray outputs. This is the historic graph. Here's the daily. And here's the 30-day. It's a pretty consistent X-ray source. Let's take a look at it on Simbad. And we'll look at it in a few wavelengths here. So there it is on pan stars in optical bands Z and G. We've zoomed way in. It's a pretty dim quasar here. It's probably located at a quite a great distance. Quite a great distance there. And here it is on the 2 mass. That's infrared light. And interestingly, there it is in ultraviolet. Not a lot showing up there at all. Some structures possibly close by, but almost no data there in infrared. Anyway, there's that distant galactic core in red light. That is the DSS-2. And you can link to all this stuff yourself if you like. Again, that's today's featured quote random end quote object, quasar B0218 plus 357, which is entry 77 at the Neil Gorell Swift Bat X-ray Observatory. It stands for Burst Alert Telescope, and it monitors X-rays. That's today's cosmology segment. We integrated into the daily space weather video. And if you haven't checked out our cosmology segments playlist, head to youtube.com/smashamash/playlists, youtube.com/smashamash/playlists. And let's continue on with the daily space weather. It's time to talk about the electron flux. Electrons surrounding Earth can charge satellites, but they currently aren't doing so. No charging hazards currently shown. Here's the 1-year chart of the X-ray flux as reported by Solon.info. And here is the 3-day chart. We're just in a moderate range. Nothing to write home about there. There's the relativistic electron forecast model. And we're expecting fairly flat levels here. If we do see a coronal hole wind stream arriving, we can expect a little lower levels than what this is currently showing. If that is indeed a coronal hole wind stream, we can expect slightly lower levels than the NOAA forecast, which is what you're seeing there. The green boxes are the forecast. The yellow diamonds are the observation. So here's a diagram of Earth's Van Allen belt because we're going to show you the total electron content next. How many electrons in the entire air column? We showed massive anomalies yesterday. If you didn't watch yesterday's daily space weather video, that's available in a playlist as well at youtube.com/smashamash/playlists. We've made it slightly more convenient for you by putting almost every one of our videos in a playlist. Anyway, this is the total electron content. It's going to show you where GPS errors are most likely to occur, which is typically around the equator at noon. And the current electron densities are looking fairly normal here. Next, we're going to show you the ionogram, the F ionosphere layer, animated to see some high vibrational regions happening here over the South Central Pacific. So there you can see making it all the way up to 14 megahertz there. That's some of the highest vibrations that we've seen on the channel for a while. We show the data daily. This is showing 2 hours of ionogram per second and 1 day's worth of data. There you can see those high vibrational zones here over South America and the South Central Pacific. They subsided rather quickly. Anyway, here's the latest image from 8:30 Universal Time. Things looking quite normal there. And let's blast through bonus features. We've got to get the video out here, so let's get going. Bonus features are starting out with the the Udaipur, India hydrogen alpha imagery. Here we go. And you can see some of the filaments here. Out here, you can see some filaments here in the northeasterly region. Here come additional bonus features, but first I'd like to thank our patrons, the true source of funding for the content. We've updated our Patreon credit crawl. Patrons are listed in order of lifetime contribution. Thanks to our patrons, you're increasing the probability that these videos will continue to exist, remain publicly visible, and free for all to view. If you'd like all kinds of updates, multimedia, and more, a lot earlier than everybody else in the world, consider becoming a patron at patreon.com/smashamash. Next, our thematic map, the GOES 16 SUVI. And you can see all these bright orange, these reddish orange regions here. Those are all filaments. So again, lots of filaments between Earth and Sun. Likelihood of coronal mass ejection is fairly high here. It's a coronal mass ejection watch despite a relative lack of sunspots. So here's the latest intensity gram. I'm going to press refresh so you see it happen. And barely any ombre there. Here's a colorized magnetogram. So I wouldn't be surprised to see us drop down to 0 sunspots today. This one here is 2839, I believe, although I'm forgetting the numbers, because there's quite a lot of stuff going on. Here's some more imagery for you. And since we should have some C-class flares here on the imagery, I figured we would bring up the 94 angstroms, which is one of the ionized iron spectra. And it looks like those C-class flares must have come out of sunspot 2835, which has already set over the limb. And we'll zoom in a little bit here now that we've showed the time and date stamps. Anyway, thanks for tuning into the Daily Space Weather. Don't forget to press like and subscribe if you enjoy the content. Tell your friends and foes about the channel, and may that solar wind be at your back. The Daily Space Weather, a recurring theme at Smash News Network. Least busted. Name it news.